Well, as you can see on the screen here, I actually have that Amiga 500 motherboard working. Sadly, all of the video I shot that showed what I went through has been essentially lost. I shot it in 4K 60 frames a second. I had all kinds of heck getting it transferred to my PC. The editing software doesn't like it. It was ultimately a mistake doing that. I've done everything I could to recover the video and I haven't been able to. So instead I'm going to go ahead and replace a couple other chips on the board and show you the process I used to replace them, and hopefully still end up with a working Amiga 500 motherboard. So let's dive into that. So I've got the 500 on the bench here and working. You just saw the screen a moment ago. What I did to repair it was I went ahead and pulled these 4 ICs out and just replaced all 4 of them. It's a couple of LS244s and a couple of LS373s. And it seems like replacing these has fixed whatever that intermittent issue was. The board has been pretty solid here since then. I'm going to go ahead and reset it one more time. And it's accessing the floppy and trying to read. And we get down to the screen where it says insert the workbench disk. So let me turn the power off and disconnect everything. Really sucked losing all that video. I had a fair amount of video shot there and all my excitement when the board came to life and worked and all of that. Like I say, at this point is lost. I've looked at a number of different options. I got the 8 GB plus files transferred to my PC. I've tried various packages to break them up into smaller files and I've just had no luck. So the repair before, and hopefully I'll get this in frame, was I replaced these 4 chips, and apparently one of them was the problem causing the memory issue. The board's ran solidly for some amount of time. It's been reset a bunch of times. It always comes up. So how did I replace these? We'll go ahead and jump into these what are they? There are 74 F244s over here. So I made mention in the other video, these are LS devices, LS244s and LS373s. That's low power Schottky. These happen to be F devices, so 74 F244s. F means they're fast, so they have less propagation delay through the devices than these do. The designer of the board felt like the F devices were needed here. They're more expensive during the build, typically. So you only use them when you need them. So I will need to replace these with F devices. I do have some of the F variants. Make sure, yeah, they're 74 F244s. I do have some of these in my stock. So I'm going to go ahead and replace these, the same process I used these, and hope I don't actually break the board. So how I approached this was as follows. So these devices have got leads folded over. Again, I don't know if you can see this, I don't know if it's on camera, but the leads have been folded over to hold the devices in place while it was wave soldered. Makes them really difficult to pull out. And instead of trying to pull the devices out and save the ICs, I'm just going to cut them out. And by cut them out, I literally mean I'm going to cut them out. I'm going to take a pair of flush cutters. They're nice and sharp and fairly new. I'm going to hopefully find the glasses that I can see a little closer up with. And I'm just going to go to each lead. And I'm going to work the cutters down in there. And I'm going to literally cut it off, if I can, as close to the package as I can get it. Now, part of why I'm doing this is I want to protect the printed circuit board. I don't want to lift traces. With these devices here, I actually went through the effort of straightening the leads, desoldering, and trying to remove the devices, and pretty quickly determined that getting all the pins loose at one time was almost impossible. I was afraid trying to pull them out intact was going to damage the printed circuit board. And so the best bet in my mind became what you see me doing here, and I'm following a little different process here to do that. And then I'm just directly going to cut the devices out. Now, of course, with this process, if it was memory devices like we have in the bank down here, you'd probably want to keep the devices intact, and that would make this a little more difficult, again, based on the bend over leads, the large ground planes. The bend over leads hold the leads up tight, essentially against one side of the via, and it's really hard to get that solder to clear out of there such that the lead's free. And spent a bit of time trying to do that on the 4 devices up here. Let me see if I can kind of get this in centered here so you at least can see somewhat. The 4K video I shot, I zoomed into and still wanted to have quality video so you could see a little closer what I'm doing. Somebody had asked for that in a previous video and just didn't have a whole lot of luck, like I said, actually consuming and editing that video. These are a little tricky to get down into. I'll try to get up closer to the camera when I get to the other device and cut a few leads up close. The hard part here is I have to get one of the points here on the cutting tool down between the legs, and the legs on these are fairly wide, so it's a very narrow gap. There's a reason I'm leaving the length here, and that's to get something to grab onto when I heat the solder so I can pull the lead out. Let's see if we can get this last one to cut. Maybe. Hopefully he'll just walk up out of there. He's got a lead that didn't thoroughly cut. I don't want to stress the board too much here by pulling. So hopefully you can see what I've ended up with here, trying to get it center of the camera, is the legs of the device still on the circuit board. I don't know if I can do this up in the air. A little hard with everything floating here, but I am getting up as high, close to the package as I can. I'm sure my hand's in the way. And trimming the leads away. As best I can. I've used this method in the past on boards that we really couldn't afford to lose the board, and we wanted as little damage on the board as possible. These were some deck computers that the Air Force was using at the time in a very early flight simulator, at least a very early digital flight simulator that I ended up working on as a very young man. So we've gone ahead and successfully clipped these devices out. They are officially trash. Gonna grab the soldering pencil here. Of course, I'm taking a risk on damaging the board doing this after getting it working. But for the good of the channel, I will go ahead and do this. Do I have... Yes, I do. What I'm looking for is sitting up here. Get it off the tool rack. I have a pair of forceps here, and I'm just going to hopefully heat the lead till it moves, and maybe use the forceps to pull it up out. Problem is the forceps are acting as a heat sink, which makes this a little difficult to do. Kind of get a rhythm going here. Hopefully my head's not in the way. The forceps have that little lines cut into them on the inside, which give me a bit of traction to help catch the lead. So he's taking a lot of heat to get moved, but he's out. Yeah, it's a shame I lost that other video. I was very excited. And this one's being stubborn. Very stubborn. Very excited when I actually saw the system light up. See if I have better luck coming in that direction, where I can actually touch down onto the pad. Yeah, that's working better. So I'm actually getting the pencil tip down onto the pad. This is a ground. I believe it actually came out okay. Let's walk through this side. The pins up against that resistor network are going to be somewhat interesting. Hopefully this is in frame. Again, everything I'm doing here is to ultimately protect the fine little traces on the circuit board. So the solder just grabbed onto him. He really doesn't want to lift up out of there. Doggone it. See if I can get him to stand up a little bit. Again, I'm not pulling really hard here, just letting this. I get down onto the pin in the pad. I see the solder release. The pin moves, which tells me the solder's flowed all the way through the other side and is wet. And then just pluck it up out of the hole. I'm going to spin the board around so I get a better working angle on this side. This looks like it's a ground or power. It'll take a little more heat. Still hasn't released. There, it's loose, except it bent over. Get it stood back up again. Hopefully I'm not going, like I said, to damage the system. I'm kind of rambling on here as I work through the pins. Patience, time, one pin at a time. Making sure I'm only touching the pad and the lead with the soldering pencil tip. I don't want to slip and scratch across the board, so I'm not pressing very hard, just gently holding it in place there. Now these are going to be a bit of a challenge because they're up against that resistor network. See if I can even get a grip on it. That's power there. It moved there, plucked out. So it took a lot of heat on that one because it was on a power rail. Looks like I can actually just use the soldering pencil It's actually working well. Because the lead's got a bit of a lip where it's bent over, I'm able to get it to move. It slides up against the resistor array, and of course this one's going to make a liar out of me. And this is that one. Wow. Of course, the second I thought that was going to work, it didn't. What a pain. So in this case, I'm using the soldering pencil tip, and the little flat blade screwdriver. It's kind of a fake pair of tweezers. There's a lot of thermal mass here again. That's a power supply rail. So all the pins have been removed. I'm now going to actually flow a bit of fresh solder onto every one of those. A little bit of fresh solder will make it easier to solder back out the holes. Speaking of which, let me get the soldering tool warmed up. If you're having trouble desoldering something with one of the little hand desoldering tools, or one like I've got, the Hacko, add some fresh solder. The fresh solder will help transfer the heat, make things a lot easier to unsolder. I've fought things for ridiculous amounts of time that just don't want to come loose. Add a bit of fresh solder, boom, out they come. So I will call that a pro tip. I'm just going to walk through each of these. Adding a little bit of fresh solder. Again, I'm on a power rail here. Takes more heat because of the large copper surface area. I've got the pencil at 350 degrees C. That's the temperature I prefer to work at. Cooler is always better. Do a point. If you're too cool, you're going to work hard to get the device released. I just want to touch down. I'm doing my best to float the tip on the board and not push it down onto the board. I don't want to be scrubbing the board here with the tip if I can avoid it. Scrubbing action could, of course, rub a trace off or lift it. That one didn't want to desolder. I'm not sure why. I just moved on past it, and I'll come back to it. Cleared out except for one hole. I don't know why that one hole's being tricky. I'm going to try it from the other side of the board. First, I'm going to apply some fresh solder back down on there. and that got it. Let me take a look here through all the holes. They all look nice and clear to me. Let me get a piece of white paper. They kind of hold in between them to see if maybe they'll show up a little better. But the holes are all nice and clear. I don't see any solder flakes or little solder balls anywhere. I happen to already have two 20-pin dip sockets here. These are dual wipe dip sockets, meaning there is metal on both the outside edge of the socket and on the inside, so the lead is actually contacted on two sides. If you've seen my other videos, you know I use blue painter's tape to just kind of hold things roughly in place. It releases very easily from the board, doesn't leave any residue behind. I am going to tack down just 2 pins on each socket in opposite corners. And in this case, they're signal pins, they're not power and ground. I'll show you why I do this in just a second. Peel the tape off. Then I put some pressure on the socket and reflow the solder just to make sure the socket's actually flush. That lead wasn't. And now it's just a matter of soldering all those connections to the fresh socket. Not sure I'm in frame here. Hopefully I am. It would be my luck to get this shot and discover everything was out of frame and it's also unusable video. And then I'd be unhappy. This is one of the power rails. It'll take some more heat to get to flow because of the large copper pore, as is this. Don't like the looks of that solder joint, or that one. Didn't have quite enough solder on them. Retouch that one. I'm not happy with it. Been too long since I've cleaned the tip. Again, this has got a large copper pore to it. It'll take additional time and heat. There's a via there that just had no pin in it. It's just a via to transfer a trace from the top to the bottom of the board. And when I used the desoldering tool, it actually lifted the solder up out of it. So I just filled it back in over there. Let me look at each one of those solder joints just to make sure I'm happy with them. And I see a cold one. Oh, come on. Oh, good Lord. Stay up there on the bench. Jeez. Now I've lost sight of the one that looked cold to me. That one's rather gray. So we've socketed these two devices. The socket notch is where the silkscreen notch is. Those were, I believe, it's one of the 373s from earlier. They were F244s. These should be F244s in the back here. 74 F244s, and they are. Get those down into, these look like they're brand new parts. The leads are nice and wide. There's one. I'll try to do this on camera. What I'm doing is laying the chip down on its side and then just rocking the body to kind of bend the pins back more towards where they're straight to the body of the IC. That replaces the two of those with socketed devices. I have nothing laying there that's going to create shorts under the board. To put the other glasses on. Nothing got into the power connector. Hook the floppy drive back up. So let's do the cable first. I'm going to move the head down so the drive is forced to step it back to track 0. There's another sign of operation. We have power, we have, well, that one wasn't in the socket very well. We've got the two, hopefully we'll see the head step back here. I'm going to go ahead and apply power. Hopefully I'm not looking at a yellow screen here in a second. Nope. White screen. I ended up here before. So I've got the white screen, but it's not attempting to step the heads around. And when it was doing this before, I reseated the Paula chip. Actually, let me use the right tool here. And that seemed to help. So I'm going to actually take it all the way out of the socket. I can see that this chip is in the socket odd. It's like the pins have been bent. The chip has been stressed at some point. Yeah, the leads certainly aren't square on him. Or her. Socket's not broke. We got past the yellow screen, which says it was seeing memory. We got all the way to the white screen, so it's a good sign. Power rails back on. Oh, need to actually enable them. Okay, I've never had that happen before. The UI on the little Rigol power supply just hung up. Hopefully my power supply didn't just die. It's booting. All outputs on. And enable them. Oh, you saw it. So the head stepped back, it's attempting to boot, and we have the screen showing the insert the floppy. So obviously an issue with this guy in the socket, maybe just by this side of pins were kind of bended and this side were flayed out, and I straightened the pins up so they were more square into the socket and reinserted them. So it looks like we've replaced these two F244s, and we're back to the magic boot screen. Let me pull the camera out and I'll just show you. I can do a reset here. I'll try again. Oh, the clip lead actually needs to be grounded before I can touch the reset pin and restart the system. I can actually touch the pin. Oh, the ground lead popped back off. We'll try it one more time. There it is. No, I actually must have shorted the 5-volt rail because the Asian characters there are the video converter, and boom, straight to, I heard the floppy drive access. So I think we have a working system. Sorry for the clumsy camera work here as I slide it back into the mount. I'm sure that wasn't fun to watch. So we got through the issues with the Fat Angus with the replacement chip in a previous video. When I replaced these 4 devices here, that got us to the point where we got all the way to the boot screen. So one of these chips I think was causing the memory issues. Replaced these 2 just as good measure, and so we'd have some video to talk about what I'd done earlier. I've 2 times had it not get to the boot screen. The first time I just put pressure on Paula and it fixed it. The second time you saw me pull it out and reseat it. It's trying to access the floppy. I think if I had a working workbench disk, the system would potentially work. I'm going to go ahead and put the additional 512K of RAM on the bus. I'll bring back up the power supplies. Right now current draw is 1.9 amps, 2.03, 2.18, and so the power supply draw comes up by I think about 30 milliamps with this board on the bus. And I'm looking at the workbench screen again, so pretty happy with this. This was a dead motherboard when I got it. I bought it. You know, it didn't say it worked, didn't say it didn't. It was just kind of like, here's an Amiga motherboard. I think in the first video I talked about it. It looked really clean in the photos overall. We've, of course, done the repair down here of the blown out trace, lifted trace, using the capacitor lead to do that. We're back at the boot screen, which pleases me. Let me turn the power supply off. Decable everything. That is really tight. I don't know if you can see down in there, especially with the shadow, where the lead comes off the bottom of the capacitor to the resistor underneath and then wraps around here to pin 2 on the hybrid. That's a 5-volt rail, and then the flying lead here just simply goes to ground. I'm guessing these large bulk filter caps on the 5-volt rail on both sides of the video are to clean up any video noise in the system, just to get a nice solid DC level for the video circuitry. So replace the trace, replace the chip, resoldered the 68,000 and a couple of chips over here. Replace these 2 devices, replace these devices. You saw me in an earlier video do solder work on a bunch of caps. I resoldered the power supply connections and where the choke is here. In case one of those was cracked, you get mechanical stress poking a cable in and out that can crack those solder joints. So there it is. I think we have a working 500 motherboard. Now I got to figure out a keyboard. So with that, I'll wrap up and we'll talk soon.